We are continuing in our discussion of microprocessors, and we're looking at bus networks. In a microprocessor, a means must be developed whereby the microprocessor can access memory. Okay, so here we have the microprocessor, and it needs to access memory. Now, the first subject is address lines. They will be needed so that the location of the memory can be specified. So we're going to have some lines coming from the microprocessor, and there will be a group of lines. And what they're going to be doing is they're selecting the address of where is the memory. I think often when we think of memory, we think, well, the memory is just over there, and we just put stuff in it and pull it out. But, well, how is it that we pull it out? Well, the memory has a specific address, and so we have these things called address lines. Data lines will be required for the actual data to be written into and read from the memory location. So then we have another group of lines, and these lines are going to be used for the data. Now, this is the actual data that's in memory. So the address lines finds the data, and then the actual data is moved back and forth between the microprocessor and RAM. The number of data lines and memory lines will be dependent upon the architecture of the microprocessor and memory. And then there's going to be another set of lines I'll just mention real briefly here. I'll put a C here, and these are going to be the control lines, and these will determine, you know, is it writing, is it reading, what is actually going on with this addressing and this data movement. So we're going to look at a system, and we're only going to have 1K of memory. We're just going to do this for purposes of simplicity. I know that many of you have got machines with 1 gig of memory, but just for purposes of simplicity, we're going to deal with only 1K of memory. And so 1K, we think of 1K as 1,000, but if you take 2 to the 10th, actually it's going to be 1,024. So we're thinking in terms of 1K of storage locations, and at each location we're going to store 8 bits of information, 1 byte. So here we have this system where we can have 1,024 bytes of memory. And let us assume that a sequential program is already stored in memory. Okay, so here we've got this memory, and we have got 1024 bytes of information in it. Well, how many address lines will be required? Well, we've got 1024 bytes of information there, and so what we'll need is a binary method to be able to access them. And so what we're ultimately going to need is going to be 10 address lines. Now, the reason 10 is because 2 to the 10th is 1024. So if it was a larger memory, we'd have to have more address lines. So in our representative system here, we're going to need 10 address lines, because it'll take 10 digits to count up to 1024 in binary. So this answers this. Okay, how many data lines? Now, since we just have an 8-bit system, we'll just need to have 1, 2, 3, 4, 5, 6, 7, 8. So we'll have our 8 lines to, now this is where the actual data is going to be moved in and out of our memory, is via these data lines. Remember, the address lines are addressing where is the memory, and then the data up here, this is the actual data that's being moved in and out of memory. Then there are the control lines, and I'll draw a few lines over here for control lines. They are needed to control the movement of data in and out of the processor. And the number of control lines is going to vary from processor to processor. They have their own unique special designs. But in order for a microprocessor to interface with memory, it's going to require address lines, data lines, and control lines. The lines connected to the data are called the data bus. Okay, we have a specific name for those data lines. It's called the data bus. The lines connected to the address lines are called the address bus. Another set of required lines in a microprocessor are the control lines, and that is the control bus. Note that the address and control information are a one-way process from microprocessor to memory, so it tells you who's in charge here. The microprocessor sends the address, sends the controls, and note that the data can go either way. So if this is a read operation, the microprocessor tells the control, I want to read, and so information comes from memory to the microprocessor. And if it is writing, okay, the information has been developed in the processor, and now we're writing that to memory, that would be a write operation. And just note, data can go both ways, but address and control one way only. And if we had the 8-bit system with 10 address lines, there would be 10 address lines here, and then there would be 8 data lines, and then we'd have control lines. And these, your text doesn't go into these, but these are the runs that you see on a circuit. In fact, we mentioned this way back in the early chapters of this book when we talked about system boards, and that the runs, and sometimes they have multi-layers. Anyway, these are physical wires that would go between the microprocessor and memory on a PC board. Okay, the address bus and the control bus go from the microprocessor to the memory, since the microprocessor must tell the memory where to store, where to store or to read the data. Okay, this would be the write and the read operations. When, okay, it needs to tell it when to read or write data to memory. Actual data transfer between the microprocessor and memory occur during read and write operations, which are controlled by the control bus. And this is an example of a memory module. We're not doing anything quite this spectacular here. This is a 240-pin DIMM. These go up to 8 gig of RAM. These are relatively new devices. They have 64 data lines. Okay, our representative system has 8. This has 64, and it leaves 176 for things concerning address and control. Our subject is not to go into the DIMM, but I'm just showing that as a representative of a sample memory device. Okay, so in this section, we're looking at mainly the address bus, the data bus, and the control bus. And our representative system, we're doing it at a very basic level. We're looking at a 1K of memory with a 8-bit or 1 byte per location system.